Okay, welcome everyone to lecture 12 of Visualization for Data Science. Today, Devin will give us an introduction into advanced JavaScript and some advanced D3 concepts such as brushes and views. So, Devin, feel free to get started.
Sure, sounds good. Let me just share my screen. Not that screen. Yeah. I'll do it this way. Cool. So as Alex mentioned, we're going to be going over advanced JavaScript concepts as well as some advanced D3 concepts. And we'll start with JavaScript here. And the first category of things is related to destructuring your data. So imagine you have a list with 3 elements out of it. One way that you can pull out the first, second, and third elements from that list is just indexing into them as you normally would. And if you run this, you can see that first line prints this array, and second line will print these 3 different elements. Another way that you can destructure this is by having the values that you assign to inside of this array. And in this case, we are using the spread operator, which is spreading out this variable we were calling array, and then we're actually putting that into a new list that gets assigned to first, second, and third. So when we print this out, we see the same output in our console. And actually, in this case, the spread operator is a little bit redundant. So if I delete that, you can see just from this array with 3 elements, we can assign it to this first, second, and third element in this array. A scenario where there is a difference between this array and then the array with the spread operator inside brackets is when you are making a copy of a list. So here we have our original array with values 1, 2, and 3. One way that you could try to make a copy of it is just by assigning copy1 to the same variable name. And then here, copy2, we're instead using the spread operator inside the brackets. And if I run this, we see the original array is updated so that cat is that second element, but copy1 has also been updated because copy1 is really just pointing to that same data structure original array, whereas copy2 is pulling out those elements and really copying a new list. And it's worth pointing out here that this is still a shallow copy. So if you have a deep nested structure, it's only going to copy those first elements. But in this case, it's just numbers, so it works. If you continue with these arrays, there are some other attributes. So here we have a longer array of 10 elements. And if you want, say, the first 3 elements and then the remaining arrays, you can again use the spread operator. So if we log this, we can see that first we get all 10, and then we're printing 1, 2, and 3. And then 4 through 10 is this array of 7 elements. So yeah, this is something you can do if you just want to get a shorter list with those first 3 elements chopped over and don't even care about those first 3 elements. This destructuring that we see here also works with nested lists. So here, instead of a flat list of 1 through 8, we have some of the elements themselves being lists. And this can go down any number of levels. And as long as the variables match this structure, we can pull it out in sort of a convenient way, which is what we're seeing here when we print 1 through 8, A through H. One kind of handy trick for this type of destructuring is if you want to swap 2 values, instead of creating this temp variable for storing one as you're swapping them, you can just set X and Y. Again, we're destructuring this list, 23 and 32. And then to actually swap it, we can say XY equals YX. And we see here, again, that those values have been successfully swapped. It's worth pointing out that you can also use the spread operator in function arguments. So if you create a sum function that will sum a list of numbers, if you want to allow the caller of this function to, instead of passing a list, pass in some unknown number of arguments, if you use the spread operator, this will convert or give you this variable numbers as an array of numbers. So here we're just summing over them and then returning it. And we can see here, this will work for, calling my sum with different numbers of arguments. And just like in the array above, we can still have like some first argument here that gets pulled out separately from the rest of your arguments, so to speak. Looks like we have a couple comments in chat. Looks like that's answered already. Okay. Cool. So moving on to destructuring objects. The concept is really the same, but here we have an object for Led Zeppelin, which we're calling Led Zeppelin, which contains the name, the active years, and the members of the band. And if we run this, we can see the object has this sort of nested structure. We can pull out these different attributes of that object. So we can pull out the variable name, which is going to be Led Zeppelin, the active years, which is going to be this string, and the members, which is going to be this array. And we see that here, when we print it out, we get Led Zeppelin, the years, and then this array object. And here again, if instead we use the spread operator, we can log that not as an array like we see here, but as this list of the individual members in the band. Looks like there's another chat. Okay, cool. And to take this one step further, we're going to construct first a more complicated object. So we still have the name, the active years, and the members. But in addition to this, we're going to create these two album objects, the Led Zeppelin album and then the Presence album. And then we are going to add them to an album's attribute on LZ. And if we look at the log, we can see this nested structure, which still has the active year, the members, and name. But in addition, there's this list of albums, which each of those are themselves the objects. And to take this to the extreme, you can still destructure this complicated nesting as long as the structure of your variables is going to match the LZ. And that's what we've done here. We get this name and the albums here, and it pulls it out. Yeah, in practice, I can't say I do this too often, especially with a list of unknown numbers, an unknown number of elements, but you can technically do it. And one other thing is, while you're doing this destructuring, you can define a default value. So here we're trying to pull out the reunion dates from this object called LZ for the Led Zeppelin information. And if you look at everything we add, or if you look here, reunion dates doesn't exist. So one thing that's kind of handy is if you set this equals not a, NA, this value can be really anything you want it to be. But if you can't find this attribute, it will set the value to NA. And that's what we see as a final output for this section. there will be no group activity today. So the last thing to mention here when it comes to destructuring, if a function is going to return a list or an object, you can destructure it in the same way as if it was a variable. So this function is returning a list that contains these three things, and then on this single line we can pull out the A and B and C elements from that list. And again, same concept with this function that returns an object with first, second, and third. We can get first, second, and third here. So just to run that, we can see it logs A, B, C, and then the values of these first, second, and third, which is X, Y, Z. Cool. So moving on to promises. Promises are a relatively new concept in JavaScript that have to do with running asynchronous functions. And they are really like, in terms of functionality, they aren't necessarily adding anything novel to the language beyond really helping write cleaner and more organized code. So to take a step back, when I say asynchronous function, it refers to something that may take a while and may not return right away. And you can think of this as from the name, you can say you all have made a promise to finish homework 5 before some deadline, but it doesn't mean that you're constantly working on it now. And in the meantime, you're going to do other homework, eat, sleep, and do all these things. But once you have submitted your homework, then I have the ability to begin grading it. And there again, I have this sort of promise to grade your homework by some indeterminate date. But there is not I'm not going to be like constantly doing that. I'll be doing other things in between. So this is useful in JavaScript on web pages where you click a button that say loads a data set. You don't necessarily want to block the user entirely on your data set while that data is loading over some number of seconds. So in terms of the state of this promise, there's a few different things that it can be. It can be fulfilled, which means that it is completed and completed successfully, as in the data has been loaded, the homework has been graded, and there's another form of completed, which is rejected, which is completed, but it has failed. So I've given up trying to download this data, or I've received some error while downloading this data. And then pending obviously means that it is pending. It hasn't fulfilled or rejected. It is not complete yet. And settled is really a kind of like a logical and of or a logical or of fulfilled or rejected. So it's no longer pending. It is completed. It is either fulfilled, so it's completed successfully, or rejected or completed unsuccessfully. So in terms of the syntax, you've seen this in some of the homeworks, specifically related around code that is doing like a d3.csv or d3.json. But in general, any function that is what we're calling here an async with promise that returns a promise object, you can do this .then and .catch like chaining syntax. And .then really is just saying once this promise has been fulfilled, right? Once the data has been loaded, once the homework has been submitted, then we can do these other operations that are dependent on them. And the catch is saying in the state where it's rejected, in case we fail to download data, then we do some handling of that failure in this catch. Yeah, and then instead of chaining it, you can also pass in two arguments which handle these two cases. The first being where it works, and the second being the scenario where the promise was rejected. Yeah, so prior to this, we have like, you know, what you end up having is a lot of like nested and really hard to follow chains of callbacks. And I can speak from experience that this can get like very painful to step through and debug, especially when you're working on large projects or with like large groups of people. See. Yeah, so yeah, whereas if you have these async functions, it makes it a lot more like this sort of sequential chain of steps that you see all the time in programming. So as opposed to these passing multiple callbacks in all these different async functions, you can have these three tasks put up just line by line. Yeah. And yeah. So when it comes to these async functions, there's another keyword that makes this style even nicer in some scenarios, which is this await function or await keyword. So in this example, let's say we want to get the first user from a list of users, and we get those list of users from this function called getUsers. And getUsers itself is an asynchronous function. So you can imagine it is querying a database or looking at a file and returning a list of users. And obviously, if we want to grab the first one from that list, we need to wait until this function returns. And we can use the same .then that we see above and set, users in that .then. But a handy way to do this is actually with the await keyword. So if you put this await keyword before this asynchronous function, it's saying wait until this evaluates, and then instead of setting users to a promise object, you're going to get the value, the resolved value from that promise. So then you can treat it just like as if it was a data element, where users is a list. You just have to grab that first element from the list, and then we're returning the name attribute in this sort of made up example. And if you want to do error catching with this style of syntax, it's just like a non-asynchronous function, right? You wrap your code that could have errors inside of a try catch statement. If there's no errors, this code will run successfully. If an error occurs, then we will catch it, and instead, in this case, we specify some default user that will be returned instead of throwing an error. So one question you might ask is, okay, so if I want to just get that first user, now we've defined this function. What if I have this line of code, let user equal get first user? And the important thing to be aware of here is that these when you use await within a function, it kind of automatically makes that function asynchronous, right? So in here, we're waiting for this asynchronous function to finish, which means this can only return once the asynchronous function has returned. Therefore, this function is also going to be asynchronous. So when we look at this line of code, user will actually be a promise object rather than that string of the resolved value of that promise object. So if you wanted to get that, you'd have to do a similar thing here where you either await that asynchronous function or do that same .then syntax. Yeah, and it looks like that was the question in the chat, basically. Cool. So I think this all will makes a lot more sense to me, at least, if you look at some sort of specific examples, and these will be similar to things that we've seen in the homeworks as well. Specifically here, d3.json is one of these asynchronous functions that returns a promise. And so your code needs this mydata.json in order to create its visualization. And the way we've set this up is we have this console.log. So obviously that's the first thing that gets printed. We define this asynchronous function, which, as if we step through it, we can see it does do this await for the JSON data. And here you would, you could use that data to, render your plots. After you're done with all of your rendering, you can log done plotting. And then there's, error catching here. So after we've defined this function, we do call it. And then after we call this function, we print console.log. So try and remove the sneak peek answer, but the question that arises here in terms of the flow here is, will this print hello world done plotting, hello done plotting world, or will it print hello world done plotting? And yep, as the answer says here, we can the more likely than not, the output is going to be hello world and then done plotting. And the reason for that, obviously this prints first, but when we call load data, this is now an asynchronous call. So before this is done evaluating, the JavaScript will move on and it will execute this line. And I say most likely because I think technically it may be undefined whether this asynchronous function could finish before this console.log, but in reality, in this case, since we're loading data and doing all this plotting, the log of the string world is almost certainly gonna finish before this asynchronous function. And as we look at these like printing of log statements, maybe doesn't matter so much, but this can be a common trap when you're not familiar with this type of asynchronous function. So this code is very similar, right? We load the data, right? We have the same await, and maybe you do some data wrangling here on your data. And you call load data as before, but you may think, my data is ready to go. Let me plot my charts based on this data. And this is going to not work out for you because at this point in the flow of the code, your data is likely going to be undefined or empty. It's not going to be prepared in the way that you want it to be.
Sorry, what was wrong with that one?
Yeah, so the important thing to point out here is in this comment, we're suggesting that you are going to plot your data on this line.
Like without a dot then.
Correct.
Gotcha.
Cool. So if we look at this example, we're gonna kind of show what I mean by this. So here, we're gonna print the start. We're going to get Anscombe, this data set of that fun stats stuff. We're gonna print the end and then print the data set. If we look at the output, we can see it prints, the start and done as we see here, but Anscombe here is not our data. It's a promise object that we see here. And if we open it up at this point, the promise state is fulfilled and the result is this array of values. So we can see the values here. But the important thing to note here is, one, this is a promise, not your data. And by the time I go over here and click it, yes, it's loaded, but in the flow of your code, this is gonna happen instantaneously and effectively, and it's not going to be ready when your JavaScript is evaluating, line 15 of your code. Yeah, so then if we look at this alternate example, we are still loading the same exact data set, but we're using this await function. And we're going to log the result using that await. So if we just look at what that outputs, we can see, it prints reading with await since we told it to, but instead of a promise object, we do actually get just that array. So if you need to use the actual data, this is the type of thing that you're going to have to do with these asynchronous calls. Yep, and just in terms of like coding style, instead of nesting these things inside, as always, you have the option of passing a callback function into your asynchronous function. So if you want to pull out a print as table function with your very, very complicated display logic here, when you actually call your asynchronous function, which is read with callback here, you can pass in that function as a callback. And when we actually evaluate this callback, it will get called at the appropriate place that we want here. And if we look at that, we do get this nice console dot table display in our console. Yep, and then if we look here, we can see as an alternate to this await, we can use this dot then syntax. So if we just look at the output, d3.csv is an asynchronous function. It returns a promise. If we try to print it right away, it's going to print a promise. And that promise has the data on it. However, if we want to use that promise, we can use this dot then syntax. So we do data dot then. This is saying after this promise has been completed, we're going to do these things, log the actual data, and we can see that the actual data is passed in as a variable in this function. So dot then is expecting a function that has one parameter, and when it's completed, it will call that function with the actual value of the data. And it's important to note here that if you console log dot data, it's still going to be a promise object. yes, that promise at this point is guaranteed to be fulfilled, and you could get the result from it. But a more convenient way to do that is to just reference that variable in the argument there. So there's a question, can we use await with then here? Really, these are like sort of two different options. You could call data.then, and then at this point, data is resolved. Or as we saw here, you can call await, and here again, that promise is resolved. So it's kind of two syntactically different ways of accomplishing the same thing. Yeah, here we are. So we saw this a little bit before, but if error is going to happen inside of your code, you can handle it with this chaining syntax, which is this .catch function. So you notice we have .then, which is saying that the data should be printed, and if there happens to be some type of error, then this function will be evaluated. And in this case, we can see that the error actually is thrown, and it's because there's an unexpected token in a JSON at position 0, which if we look back here, we're calling d3.json on a CSV file. So it's D3 is throwing an error because it's not matching the type of file format and the content that it's expecting. Yeah. Cool. So if you want to write your own promise, this is perfectly acceptable thing to do. But before we get to actually creating your promise, I want to go through this sort of pattern here. And in this pattern, we're going to have just a variable status, which equals true. But you can imagine this being, dynamically set in some way. And we are going to say we have this function called status check with callbacks. And if the status passes, we're going to call this function. So this variable is a function object. And in the same way, this variable is a function object. So if the status evaluates to true, the status passed, we're going to call that function object, and we're going to pass it this string, the status has passed. Otherwise, we're going to do a similar thing with the other variable. And oops, if we look at actually calling this function, as I mentioned up here, that first argument is in itself expecting a function. So this whole block here is a quick anonymous function, and it accepts one argument, which we're calling pass message, and it will log that message and then log, this hard-coded string. And in the other case, we have this alternate function. Yep. So, and to just go through the machinery here one last time, when this gets called, we come up here, we check the status, which happens to be true in this case, and we call if status passed. And if status passed, in this case, refers to this function. The way we call it, we pass in this string, status has passed. That string is equivalent to this variable pass message, which we log, and then we log an additional string. So if we run this, the first two lines show that the status has passed because we passed in there. and that we can now render our visualization. And then we see the same thing again in this next section of code. And the reason for going through this whole sort of structure is that this is generally the type of structure that you will use when you are creating these promises. So this status check with promise is going to return a new promise object. And when you create a new promise object, that promise object expects a function, and it expects that function to take 2 arguments, which they themselves are functions. And that's what we are doing here, all in line. In this particular case, this whole section of code happens to be equivalent to this function. So you could delete this and pass in this function name. And just to run this again, you can see that it ends up running and doing the same thing as this syntax. So after all of this, once we have this promise object return from this function, if we call it, then we can get all of this syntax that we've been talking about with the .then and .catch, or alternately the await keyword. Cool. So one use case that is interesting is the scenario where you have multiple promises. So one trap that you can fall into is, say you need 2 data sets before you create your visualization. One way you may think of doing that is, say, give me my first data set and then .then, and then inside of here, grabbing that second data set. And one disadvantage to this approach, there's a couple. One is that, you kind of get this nested syntax, but if you use awaits, maybe you don't get that. The bigger downside, in my opinion, is in this scenario, you lose out on potential parallelization of getting those data sets. So yeah, your browser can potentially, depending on how they implement it, download multiple files at once, or do multiple asynchronous functions at once. If you chain them in these ways, then the second one has to start after the first one is completely finished. So for this particular use case, there is actually a specific function within the promise object that can help facilitate this. And this is promise.all. And in this scenario, we have 2 promises, the Anscombe dataset and the Iris dataset. And promise.all expects a list of these promise objects. And it only resolves once all of those resolve. And once they have all resolved, then we see this .then syntax again. And this is similar to before, where we get our data, but it's all packaged into this, this array of results. So if we run this, we can see the array has 2 things. The first is this Anscombe's data set, and the second is this Iris data set of these letters.
And you said this may allow for like parallelization or something when the data is loading?
Yes, and this, this is going to depend on your browser primarily and how they decide to do this. But this style of syntax at least gives your browser the opportunity to try and do these types of optimizations, whereas before you're kind of forcing them to do them in sequence.
Got it. Thank you.
Cool. So that concludes the JavaScript functionality. The rest of the advanced JS lecture is going to go over some debugging tools. So we mentioned this in class. or in the first lab, I should say, but there's a number of IDEs that can help with this. The Visual Studio is what I use. That's what most of the people that I know use, but there are obviously multiple IDEs that you can choose from, and they have some differences between them. In the same way that you can set these breakpoints in the Chrome, DevTools, it's possible to link up your VS Code with the code that's running and do your debugging right within this IDE. It's not something that I personally do, but as some people prefer it that way. In terms of the console, I think at this point, all of you are aware of console.log, but there's actually a number of other sort of useful functions on this console. And the simplest one are these variants to just console.log. Console log and info, I think maybe had a difference at one point. As far as I can tell today, they seem pretty equivalent, but the .warn and .error have slight differences where .warning will give you this yellow highlighting, and the .error will give you the red highlighting. And both of them, if you expand them, you can see the current trace to this code that was run. So if you click here, you can see, oh yeah, this is where that was run. Yeah, which gets to this console.trace specifically. And let me go back here. This is probably a better illustration of it, but the final thing that is run are these two lines. So this is going to call console.trace and then console.error. And the first thing worth noting is that everything that you see within this console.trace, is equivalent to what you see in this console.error. And this can be really useful for like seeing how you're tracing back your function calls to here. So we can click here and say, yep, sure enough, that's the line that called it. But if we go back one, we see, oh yeah, so call second, called third. We can go back one more and say, yep, call first, called second. And further back, this is, kind of the start of this snippet. And then the rest of this really just has to do with how this JavaScript is run. Here. Console.time is built in if you want to, time how long it takes to get between two different sections of your code. So you can see it here in milliseconds. You can do it with no arguments, or you can give it a key. So you could potentially have multiple timers running simultaneously. And this kind of starts getting at some performance things. So if you're trying to measure your performance, you might try to time it, but you could also try to get a more full profile of the code that was run, or look at the current memory usage of your web page. And for these, you can use those. For me, I typically just use the performance tab. And when you call console.profile and profile end, you can be very precise with it, but effectively this is hitting this record button, which is doing profiling. And it's recording all the things that are happening on your web page, profiling them. I'm going to click this so we have some JavaScript running, and then I can stop it. And you get really a quite advanced tool for inspecting all of the things that affect the performance of what you're getting. And I'm not going to go into every single detail, but this is generally a timeline of the events. You can see they even kind of capture screenshots of what the user was doing. And the reason I don't usually bother putting in console.profile is because you can just zoom in on any particular section that you want. And, if we go here, you get a really specific breakdown on the JavaScript that was running, as well as other operations that have to happen on your browser, like the browser repainting things, or updating the layer tree. And really, if you are trying to improve the performance of your website, this is really invaluable tool. When we lost my place here, when we start looking at the memory, there's also a live tool here, not memory, but the performance monitor. And this actually kind of gives you a live graph of that memory usage, whereas console.memory just gives you a snapshot of what's happening here. So you have all these different options. For instance, the JS heap size is really, you combine all of your JavaScript objects, how much memory does that take up on your computer? I'm going to, yeah, there we go. Cool. And then the other little function here worth mentioning is there's a console.count. Again, takes a key and it will tell you how many times this has been run. This could potentially be useful if you're trying to debug an error that has, multiple asynchronous calls conflicting, and when you actually place breakpoints, you no longer have the problem. Things like this could maybe be useful. Yeah, and like a lot of programming languages, we can have this an assert call here, which will, evaluate this expression, and if this expression returns false, then it will be printed. So in this case, A is the number 34, and it's checking against the string 34. They are not equivalent, returns false. And this is the message that's printed as a console.error. And if you really are going crazy with all of your console statements and want to organize them, there's a grouping functionality. So here we are starting our level 1 group, and at the very end, we end it with that same key. And once you have this grouping, then you can, kind of collapse your different groups to try and keep things organized for you. And yep, the last thing, we saw this briefly earlier, but this is the console.table. So let me just show you this data set, right? This is sort of a typical way of seeing it, right? It's all collapsed. You can open it up and you can see, okay, yeah, these are the different things. But if you do that same data as a console.table, we get a little bit easier display to parse through. And you can even do, different alterations with it. Let me do this. Yeah, where you specify the columns by the key. So we're getting the sepal width, sepal length, and species as opposed to, everything. Yes, and this last example is something I want to share. I think some people are into this year. I've seen this happen in past years, and I think I myself have run into this problem. But it's worth noting that the console can be deceptive at some points. So here, we're going to load this iris data set again. We're going to log the data set, reverse it, and then log it again. And then we're going to actually do the same thing with this simpler example. So if I run this, if I look at this simple example first, actually, we can see it prints 1, 2, 3, and then it prints 3, 2, 1, as we'd expect. But if we expand this one, we also see 3, 2, 1, as we'd expect. But if we expand this first array, we see the values here are now 3, 2, 1, which is the opposite of this and equivalent to that. And we run into the same phenomenon if we dig into this iris data set. So if we open up this and quickly dig down into the first element in that, it's this 5.1, et cetera, to 3.0. And if we open up this first element, we see the same thing. And the reason that you run into this issue is because Chrome, when we print this initially, you see we have the length of the list, and it kind of puts these stubs for all of the objects. It doesn't print them directly like this array does. And when you open it, it dynamically is looking at the object D. And by the time you click this, D has been reversed. So when it generates it generates it in this reversed state. And that's why we see the same phenomenon here with 1, 2, 3. Here we don't get those stubs because it's just a list of numbers, but when we open it, it's generating it on the fly based on what exists in simple data, which is this reversed list. Yep, and then the couple other really quick things. If I have a list L and I console.log L, you can store as a global variable, and that stores it as temp1, and then you can interactively in this command line, do things to temp1. So that's useful for me sometimes when I'm exploring data or sort of debugging something. And that will work as well when you are storing it from here. And then in a similar note, if you want to copy this data out, like into a file, a simple way to do that is with this function that already exists in the at least Chrome console called copy. And if you, let's actually give it temp1, give it a variable that is copying that object as a JSON string onto your clipboard. So if I do like a command V here, you can see that we have this array with 3 things in it. Cool. And that's it for advanced JavaScript. We'll move on to.
I had 2 questions on that.
Yep.
If you go, so we'll do like in reverse order. So if you go up to the previous window, if you did console.log simple data dot reverse instead of saving it to the same variable, do you know if it would reflect it actually being reversed?
Let's see, it depends if arrays in JavaScript also reverse it in place or not, which I don't remember off the top of my head. 1, 2, 3, 3, 2, 1, 3, 2, 1. Yeah, so dot reverse does both. It will reverse simple data in place and it will return itself.
Gotcha. And then here's a question that I don't know if anybody else has had the same issues. If you try to, if I've been, when I've tried to debug before and like place a breakpoint, when I have the server, it doesn't actually stop at the breakpoint. Is there anything special you need to do?
Are you placing the breakpoint within VS Code?
Exactly.
Yeah, so we don't have those setup points here. You'll have to like Google the setup for that, but it involves creating like a launch config file and actually launching that server from VS Code.
Okay. That's what I thought. Thank you.
Okay. Yep. And as mentioned in the chat, you can also debug in the browser, which is what I do personally, but either way works. Cool. Let's move on to D3. So we got about 25 minutes left. So I'll have to go quickly here. But in D3, one really important tool that comes with D3 are the brushes. And when we talk about brushes in D3, it refers to this sort of selection in your data that is going to perform some operation. In this case, highlighting these points red. And specifically, they have pre-built things for 3 different types of brushes. Brush X, so when you're brushing across the X-axis, brush Y for the Y, and then if you're doing a 2-dimensional brush, you have just plain brush. Excuse me. And to use these, there's a few different things you need. First off, you're going to need a group selection. So brush group is simply a group element. And then here are these 3 different variants: brush, brush X, brush Y. The return value of these functions are themselves functions. So brush is a function object, brush X and brush Y are also function objects. And like the similar thing that we've seen to this before are the axis left and axis bottom functions that you've seen before. So similar to those, you can specify certain things with your brush, and one that you're going to have to specify is the extent. So how far can you move this rectangle around? And you specify that with like a top left and bottom right. So top left, right bottom. And ultimately, when to apply this brush, you need to get your group selection, which we created up here, and you're going to do a dot call and pass in this function, which we've named brush. So a couple working example. I'm going to skip to the final result really quickly. We can see this is what I mean by only being able to brush on the X and Y and up and down, and then the 2-dimensional. And there's a number of different operations that can happen here. You like resizing and grabbing these. So it's not like a trivial amount of code to create by yourself. So it's really nice that this exists in D3. So in D3, we can see, importantly, we have this brush group, and we create 3 of those for these 3 different scenarios. We give those just borders so we can see it on the screen. And then here, we are getting these brush functions where we're setting the extent based on these values, and then we are actually initializing them. So all of the really heavy lifting of creating the rectangles, making sure that you can move these around, make sure you can't push them farther from their extent, all of that's happening from D3. All you need is a group, the return of a brush X, and then you call that from your group. And in terms of like hooking into the results of moving this around, you can look at the brush events that D3 provides. And specifically, it's going to provide a start of brush. So like when you click down, a brush event, whenever that brush moves or resizes, and end and end when you lift up. And yeah, so we say mouse up or touch start and touch end, which is another sort of bonus you get from using D3, where this also works on touchscreens. So if you have an iPad, this D3 brush, it still works pretty well, which is not, again, not so hard, but not trivial to do. It's just a little bit finicky. So in this example, again, I'll skip to the end result. We have a scatter plot. We can move this brush around, and for the points that are in that scatter plot, we're going to color them red. So let's look at how we would accomplish that. And a lot of this is patterns we've seen before. We get our SVG. We have a group for the plot. We get our data set out. We get our mins and maxes for that data set so that we can get our X scale and Y scale. Once we have those, then we can create our axes. Here you can see again that similar syntax where we're using the d3.axisBottom returns a function, and we pass in a function in the dot call from the selection. Here we're adding all of our points. So we can see they're circles with the class regular, and we save that in the selection marks. And then here's where we get to the sort of new business, right? We have this brush group. So just a simple G element in your SVG. And then this whole evaluation, up to here, is going to return this brush. And after you get that brush, the last step to do is to make sure you call it from the group to like make sure everything works. But there's a number of things in this brush, as we saw before. To start it off, you call .brush. That gives you a brush. We specify the extent here. We go a little bit beyond where the data points are. And then after this, we see the event handling code. And it's just like when we're adding these click handlers or mouse over, mouse leave. But we're going to use the events that come with the brush. So that's start, brush, and end. So when you start the brush, we're going to just log brush started. And then when we end, we're going to do a console.log brush completed. And then we're going to do the rest of this evaluation. So the first thing we're going to do is we are going to get the selection. So when we are inside these functions in the callback, this is referring to the group element. And when we call d3.brushSelection, they have a convenient function for looking at that group element and returning that selection. And we'll use that in just a second. Yep. So here, there's two scenarios. That selection exists, right? It's some rectangle of size, or if you do like just a click and release, that selection is going to have like 0 size, so it's just going to return something falsy, either false or null or an empty object. But in the scenario where it's not false, it's going to give us this left top, right bottom. And here we see an example of this destructuring, which is a little handy. The selection will always be, if it is truthy, an array where there's 2 elements, and each of those 2 elements has two values in it. So it's just a convenient way to grab those. Once we have this boundary, the top left and bottom right, we can loop over our data set and then essentially check if that data point is within that boundary. And you may notice that we're using a .invert here. So the important thing to notice here is when we get left and top and right and bottom, that is in the pixel space or the screen space, however you want to think about it. And our data points are not in that screen space, right? Because we scale them to place them. So we need to compare these in the same space. So you need to either compare them both in the screen space or both in the data space. And in this case, we are comparing them in the data space. And scale functions in D3 also have an invert function. So it can take a value that's in that screen space or pixel space and invert it and get back to the value that would produce it. So you're just inverting these pixel space values so that everything is in data space. As long as your point is in that rectangle, you push it onto this list of selected indices. Once you have these, you obviously need to update the style. A simple way to do that is to first clear this highlight class from every single one of your circles. Recall that marks is a selection on all of those circle elements. Once you have cleared all of them, set them all to false. you are going to loop over your, well, you're going to say as long as I have at least one point selected. So just an extra if statement there, but you're going to look at, again, this selection object, and you are going to do a dot filter. We talked about this in lab, but these dot filters are filter functions that exist on D3 selection objects. They expect a function. If this function returns true, then the resulting selection will include it. If it returns false, it will be filtered out. So the result of this dot filter is a D3 selection object that contains the marks such that its index is in this array of selected indices that we just created. Looks like there's a number of questions here.
I think they're covered.
Looks like they're covered. Cool. And once we have this specific selection, it becomes trivially easy to set that to highlight to all of them. You just set them all to true. And then when we look at this dot on brush, we specify that it's brushing, and then everything that exists after this is the same. And we could pull these out into separate functions and call them from there. But later on, we'll see another way that you can handle sort of this duplicate behavior. And then just to show this again, now that we've seen it, when I click, you can see it is saying brush started in the console. And then whenever I move around, you get, 380, 400 calls to brushing, and then letting go will give you a brush completed. And if you move it around, you see the same pattern. And if you resize, you again see that same pattern. Cool. So if we look at D3 group and D3 groups, these are really handy if you want to group your data in some way. So in this example, we're going to again look at this iris data set. And if I log this data before it's grouped, we can see that the data that you get from this is this list. And as before, it's a list of objects. Each object has, these 5 attributes. But if we want to say group our data structure based on the species, because there's not 150 different unique species, we can do that with this D3 group. And the first function is the data that you want to group. And then the second function is the accessor function to what you want to group it by. And the result of this is a JavaScript map object, where each key is the thing that you're grouping by. So in this case, the species. We can see here there's only 3 species. And the value of that is going to be a list of those same objects such that they match this criteria. And if we look at groups, which adds this one character S as opposed to group, it's really the same exact concept, but for your final data structure, instead of getting a map with keys and values, you get nested arrays. And the first element, you can see this is equivalent to the key before, and then the second value in that array is the data. And depending on what you're using this data set for, one may be more convenient than another. And yep. And another thing that's nice about this is if you want to nest your group further, they provide a convenient way to do that, where you can, instead of providing one accessor function, you simply provide a second one. So in this example, we just have this data set with these 4 groups and attributes. And if we print it out, we see the D3 group giving a map and D3 groups giving an array. And if I open this group, we can see the first categorization is based on the name. So we see the 3 different names. And if we expand one of them, yeah, it's just showing us a key again, but the value, the things inside of that group are they themselves another map. And inside that map, the keys are the dates. So if I were to just add another Stacy with a separate date, and let me stick to the map to not have too much clutter here. And if I expand Stacy, you can see now that there are two within this subgroup, there are these two different dates. And if we open up this in particular, you can see the two values that are Stacy with this date. Cool. A really useful design pattern for visualizations are these linked views. So again, I'm going to just jump down to the final result. We have these two scatter plots. This again is this iris data set, which remember for each flower, there's like 4 different attributes. And using our brush, if I select these, it highlights these, but it will also highlight the same data with different axes. And with this interactivity, you can determine, so this kind of group up here corresponds to the bottom left group, and these other 2 dimensions, and vice versa here. And a really useful way to do that is with creating sort of different classes for the different objects and having them communicate with each other. So that's what we are doing in this example. Yeah, so a lot of this will be things you've seen before, right? We load a data set, we create our SVG, we have 2 plots now, since we have 2 scatter plots. For each plot, we're giving it a border. And at this point, we are getting into this class structure. So we are, yeah, there's no group activity today. So the first class is a scatterplot class, and the second class is this scatterplot with brush. So the second one is going to be the one that we brush, and the first one is the one that is going to update based on that brush. And the things that you pass these are all the things required to make these classes. The first, 6 are the same, right? The dimensions of the plot, the selection for that plot, the data that you're displaying, the attributes, and we can notice here that these are displaying on different attributes. The difference here is this function scatterplot with brush that needs to communicate to this other class is handed a callback function. So we'll see this action in action a little bit, but keep in mind that this callback function is at a higher level than the class. And when that callback function is called, it will update our other one for it. So we'll see that as well. So if we dig into these classes a little bit, we're going to first look at the one with the brush. Again, we see all of those sort of attributes of the scatter plot and then this callback function. And really all this is doing is setting those attributes as member variables of this class, and pulling out the relevant data for the particular X and Y keys for this data set. And after it's done all of those, it will, draw your scatter plot. And once we're here, we see again similar patterns to the scatter plots that we've seen before. We get our X scale and Y scale. We add our axes, and we now can create a group, like a brush. Again, this brush expects a group, and at the same level, we're going to create our points, our circles, our marks, which we're calling marks group. For each of those, we're going to give it a title, so you can hover over and get the index. We're going to store off an instance. So at this scope, this refers to a single instance of the class scatterplot with brush, and we're going to use that in just a second. So we're sort of saving that off there. Cool. And we use that within our call to brush. This brush, again, we initialize it by calling d3.brush. We set the extent of our brush. And before I mentioned the ability to sort of remove this duplication of code, if you want the same exact behavior for your brush event and your brush end event, you can simply add them both here with a space in between them. And for both of them, they're going to call this callback function. And the logic here is really the same as before. We get the selection, which are the bounds of that rectangle of the brush. And we, use that to find all of the points that are selected, all of the indices that are within that, that rectangle. And then the difference here is instead of updating all of these points here, we're going to use our reference to instance, which we put up here. And as a reminder, we do this because this is now scoped to this function, which is instead of being an instance of this class, is instead a reference to the group object on the DOM. So all that said, we have a reference to the instance of this class, and we're going to call .update, which again, recall, we set, oh no, getting ahead of myself. So we call .update with those selected points. And we see this function called update here, again with these selected points. We do the same thing before, where we are removing all of those highlights and setting those highlights. The main difference here with the previous example is we are now calling the callback function that was passed into the constructor. So we're calling that function update other views, and we pass it the selected points. If we look here, is our update other views. And this will flow back up here to update other plots, which in our case is going to call the controlled scatterplot.update. So just keep in mind that ultimately that's calling the controlled scatterplot.update. And if we look at that controlled scatterplot, it's really a lot of similar code. We get the same sort of, let's make a scatter plot with axes and marks. And here in this update, we are doing a similar thing as the other function. So we are being passed these selected points. We don't ever have to calculate them, we're just given them. And we're gonna do the same thing where we remove the highlight on all of them and then set the highlight for only the marks that are in the selected points. Yep, which gives us our, wherever the example is, our final output of brushing in this plot and seeing highlights in both. And yeah, with the last 2 minutes, we can point out that, with web development, there are many front-end libraries that are actively being developed. They're changing all the time. And these can be, obviously really useful. A popular one that is used very frequently is React. And you may wonder how to incorporate visualizations while simultaneously using this React library, this front-end library. And one option are to use these dedicated data visualization libraries for those libraries, such as the Victory or React Viz, which I believe both are intended to work with React. But if you want to use D3 specifically in conjunction with React, there's a few different approaches that you could take. And this is gets pretty complicated. So if you're interested, should definitely look into more, but at a high level, you can make React call the D3 render functions. And the advantage of this is it's easy to get set up and running. One downside is that this can lead to performance issues because both D3 and React are modifying the DOM, and modifying the DOM is what leads to the updates, visual updates on your screen, and being careful about how you update that DOM affects the performance of your website. And when you have two different libraries not expecting to work with each other, they can do these updates in a way that is suboptimal in terms of the performance. Another option here is to allow D3 and React to sort of control their own setup by using these sort of black box components where D3 exists. And this can be fast if you set it up correctly. But again, this is tricky to set up correctly because you have to understand how this update of the DOM affects the rendering and layout performance of the browser, as well as how React and D3 are doing those updates. So this can be tricky to get to run quickly. And then the last sort of like pattern or option would be to allow React to have total control of the DOM, and instead you use D3 to do the calculations that D3 are really good at, things like the scale, which we've seen a lot in this class. And this can be really fast, obviously, if you're using React in a way that is fast without D3. And a downside to this is there's not a lot of documentation floating around that covers this approach. And that's it.
Okay, thanks, Devin. Do we have any questions?
I don't know a ton about JavaScript and these React libraries. Would it be possible to just put them in like a separate iframe? And would that cause or like solve some of the issues, or not really?
When you're talking about performance, iframes are useful for separating out things, but in terms of like sort of subdividing your code, I don't know if they would really help with the performance really. Yeah.
Thanks.
Okay, I'll stop the recording then. And I'll be having office hours in 10 minutes.